A few weeks ago, my wife and I were at an event in our local community, and a lady came up to us who we know quite well and said, "You've got radiators on the ceiling, haven't you?" I said, "Yes." And she said, "I love that idea." She said, "I would love to get rid of all our radiators on the walls. They're always in the way of furniture, they're ugly," and so on. And I'd never considered that aspect of radiators on the ceiling. And she never asked why we had radiators on the ceiling, which was interesting. But she's very excited and coming around to have a look. So why have we got radiators on the ceiling? And I think I would respond to that question, and I do get it quite often, by saying, why not? And the big reason is it overcomes all the issues, or most of the issues, associated with conventional central heating systems, including having radiators on the wall, which I hadn't considered before. And I'm going to hear you saying, what issues with conventional central heating systems? We've got no issues. It warms us, it works, it does everything I need it to do. Well, there are issues. There are quite significant issues, I believe, with conventional central heating. The first one is most of them use fuels that we shouldn't be using anymore, fossil fuels. And we need to address that, and we need to address that with a degree of urgency. The second issue is they're pretty slow. It's not a very responsive system. You switch your heating on, the boiler fires up and warms the water in the water jacket, then pumps that around the pipe system, slowly warms the radiators. When the radiators are warm enough, they generate a convection current. So it warms the air, and the air starts to circulate. So the first thing the air does normally, it just goes up from the radiator and it's by a window and loses half that heat out the window. And then it goes up to the ceiling. And if you're on the top floor or in a bungalow or whatever, half the heat of that is then lost through the ceiling. And then it gets to the far wall and half that heat is lost again. And then it wraps around. And it's a slow time before you're up to temperature. To give you an idea, my central heating at home, which is fairly normal, fairly traditional, used to take about an hour, sometimes a bit more if it was colder, to get up to temperature, to get the house up to temperature. So they're not terribly responsive, and that lack of response is just wasting energy. You end up having to put it on earlier in order to be comfortable at the time you want to be comfortable. So it's just wasting energy, inefficient. The next thing is, as I described with the convection current, it relies on the air in the building as its final heat transfer medium between the radiator and us, so to get the heat to us. Now, the problem with that is we need fresh air to breathe. I design buildings. I've been designing buildings all my life, and we design buildings to replace the air twice every hour, so to give us fresh air. So that's part of the infrastructure we design into a building. So twice every hour, we're throwing all the air away that's been heated and replacing it with cold air coming in to warm the room again. So that's not clever. Also, by warming the air, we create technical problems with our building. Many of you will experience mold growth in your buildings. Some will experience interstitial condensation that happens within the fabric of the building, which is massively damaging. I think it's currently one of the biggest reasons for failure in modern buildings. So what is this? So you probably all know that the warmer air is, the more moisture vapor it can carry. So if you imagine you've got a building which has got air inside at 20 degrees C, and the outside air is, say, 0, 5, whatever, then as the air, if you look at a temperature curve across the wall, the external fabric of the building, it will drop from 20 degrees to 0 degrees. So at some point, it's going to give up all its moisture, or most of it. That's what we call the dew point. And if that happens within the fabric of the building, you'll get interstitial condensation. So you get moisture buildup within the fabric of the building, which will decay the building. And it will reduce its thermal performance, and it will cause possible frost damage and so on. So it's quite damaging to the building. If that dew point is closer to the surface of the building, you'll get surface mold, so closer to the inside surface. So by warming the air, we are creating these sorts of issues. So the warmer the air is, the more likely we are to get these problems. And actually, the greater the thermal performance of the fabric of the buildings, the more of these problems we find. What we call cold bridging, that basically seeks out the problem. The warm air seeks out the problems in the fabric of the building. So it becomes very difficult. I'm not a big fan of retrofit insulation because it generally creates these sorts of problems unless you have an appropriate heating system, which is what I've been talking about. Because of the moisture problem, we, by law, have to put extract units into our building. We have to suck out the air that is moisture bound. So extract units have to be put into WCs, into utility rooms, into kitchens, into shower rooms, into bathrooms, anywhere where moisture vapor is created in large quantities. We also have to ventilate the whole building anyway, which helps because we're giving off moisture all the time from our own bodies. So to overcome the problem of heating the air, we have to then add in ventilation extract systems. Now, we can improve the efficiency of this by using a heat recovery system, but we're just throwing in more equipment that has an embodied carbon issue, more equipment that has to be run and use energy, and more equipment that needs to be maintained and replaced when it fails, and so on. And there's quite a lot of equipment in a central heating system already. So, quite inefficient. And the next level of inefficiency comes from the controllability of it. And this is where I started. And I started by trying to improve the controllability of my existing central heating system. I'm reasonably competent with computers and programming and the such like. And so I started building my own programmer because I didn't feel any of the ones on the market delivered the level of control I wanted. And it was only when I was quite a long way down the road with this that I realized I was never going to achieve what I set out to do. And the reason for that is if you're warming the air, you can't control individual spaces. You can switch off a radiator in a room and you can switch on a radiator in another room, but there's nothing stopping that air from permeating from space to space, particularly going up through the building. So in other words, if during the day you want to heat the ground floor and not the first floor, trust me, you will be heating the first floor. The heat rises through the building and it goes in all directions through the building. Unless you build thermal separation from space to space, you will always be heating the whole building. So it's pointless putting in a control system that controls individual rooms and individual spaces. It serves no purpose. It took me a long time to realize that and work that out. I was a long way down the line and I'm quite disappointed that I hadn't really thought about it well enough, but we got there in the end. So my journey to radiators on the ceiling looks something like this. About 7 or 8 years ago, I was at a conference being given by the Society of Protection of Ancient Buildings. So this is the society, and I'm a member of that organisation. Where I work, we have a lot of listed buildings and historic buildings, so I'm particularly interested in that part of the industry. And I was having a lecture from this professor, and this lecture was specifically about improving the efficiency of historic buildings whilst maintaining their character and their general performance. And during the lecture, he mentioned far infrared radiant heating panels. It's not an easy one, but many words there. He mentioned these, and I'm thinking, I've never heard of this. I've never heard of these. Now, I know what infrared heat is. We've been using it. It's what the sun gives us. It's what open fire gives us. And we've been using it for years on problem buildings. If you've got a big sports hall or a shopping centre, if you've got village halls, schools, Any big volume factories, that's the one I was trying to think of, any big volume of, you're never going to heat those with a radiator. It's ridiculous, with a conventional air heating system. So infrared heat is what we use for difficult to heat buildings. So those heating solutions are generally what is termed near infrared, so within the visual spectrum. So you see them glowing red. You get them in pub gardens and restaurant gardens where you're sat outside on a cooler evening. You wouldn't use a conventional radiator in that situation because you would have to heat all the air around the planet before you felt any benefit. So we use infrared in those situations where you need local heat, and a lot of it. So I'm quite accustomed to infrared heat, but I'd never seen or heard of far infrared panels. So I grabbed him after the lecture and asked him to tell me more. And during the lecture, he said the reason these are good for historic buildings is there's far less intrusion, so you're not having to drill holes so much through the fabric of the building, so less damage to the building. They're easy to hang onto the wall or ceiling. And radiant heat is far better for the fabric of the building. So most historic buildings are damp. Well, all of them are damp, to be honest. And if you've got a radiant heater that warms the fabric of the building, then it helps to mitigate that damp, helps to dry it out, which reduces the damage to the fabric of the building. You're less likely to get frost damage. You're less likely to get interstitial condensation and so on. So much better for the building. So I've got a listed building, not my home, but my office. This office here is a historic building and listed. And I thought it would be interesting to try it because I don't want to specify things for people that I haven't personally experienced. And so over the following 12 months or so, we slowly introduced infrared panels. And I say slowly because I was experimenting with it. I was trying different sizes, different positions, different arrangements of them. And eventually, after about a year of that, we settled on a solution, which is what in far infrared terms is termed local heating. And what is meant by that is you're just heating the spaces where we are. So instead of trying to heat the whole volume, and this is a big, it's a horrible, this is the worst building you can imagine to heat. We've got no thermal insulation whatsoever. We've got solid stone walls. We've got nothing in the roof. It's a vaulted ceiling. There's no insulation in the floor. It's drafty. It's single glazed. It's got a lot of glass. It would take 12 kilowatts to heat just this room alone under normal circumstances with a conventional air-based heating system. So it was a really good test for us. It was a really good one to experiment with infrared here because this is the worst building you will ever find to heat. And we're heating it with, what are we looking at? 2.6 kilowatts of heat now. So as far as the infrared is concerned, we're using 2.6 kilowatts, but we're cheating. We're heating locally. We sit in the same places. I sit here all day. My wife sits there all day. And we've got heating panels on the side here which warm us. We've got panels at the far end of the room that heat the meeting space. We've got a panel that heats the kitchen. We've got nothing that heats the toilet. So we have become fairly accustomed to this heating system. When I was looking at my home system and I hit this brick wall, as far as control system was concerned, I'd shelved it. But I was still moving towards putting in an air source heat pump. I wanted to put an air source heat pump in, but I wanted to increase the controllability of the system at the same time. And I suddenly had a moment where I thought, you know what, the solution here is a hybrid. If we put infrared panel, I knew the top floor would be fine with the radiators that were up there. The system upstairs was fine. It would deliver the temperature I wanted off an air source heat pump. It was the ground floor that was marginal. So I thought, if we put some infrared panels on the ground floor to supplement the central heating system with an air source heat pump, that would be brilliant. Because in the transition months, at the start of the cold season and the end of the cold season, It's crazy having a big central heating system running to give you a little bit of heat. It makes them, again, massively inefficient. So I thought during the transition months, we use the infrared panels. And then we size the system to suit the bulk of the winter, not the peak cold of the winter, which is what we normally do, which will further increase the efficiency of the system. So we could end up with a system whereby far infrared is used transition months, air source heat pump is used through the bulk of the winter, and during the really cold days, both systems come into play. And I'm thinking that's brilliant. So I went out to the two biggest suppliers in the country of air source heat pumps. They flatly refused. The argument that they both gave, and these are companies that everyone will be aware of, and one of them in particular, has got a vested interest in fossil fuels, so they're probably not that excited by these things anyway. So they both said the system has to be your primary heating system. And I said it will be. It will be my primary heating system. I'm supplementing it with infrared. And they said, no, that's not good enough. And I said, well, if you look at the wording, if you look at the government's wording, I think it is good enough. But they refused. And obviously these people, they want to make money out of replacing your radiators, and the contract they were putting in front of me sort of made, I had to sign that I was happy for whatever radiators need to be replaced would be replaced, whatever pipe work needed to be replaced would be replaced. I had to sign for that up front, which you'd have to be pretty foolish to do that. So anyway, I walked away from it and thought, I need to do something different here. And one of the things I could have done was just put in an air source heat pump without the government grant, and that would have been a fair solution. But I thought, you've still got a horribly inefficient system. The IR panels are helping, so you're improving the efficiency, but you've still got all the inefficiencies that come after the boiler as far as your control and your heating system is concerned. So what we did was we designed the system ourselves. What I was keen to do was to use an array of panels on the ceiling. So a little bit different to the way you use a normal central heating system where you might have a single radiator on the wall that then, say, through convection, warms all the air in the room. With radiant heat, it's line of sight heat, which is why the ceiling's such a good placement. But if you've got a single one in the middle of the room, imagine having one above a dining room table. So you put a radiant panel above the dining room table, you sit at the table, your knees are in shadow. The heat is, the table itself basically forms a heat shadow for your legs, so your legs will be cold. So what you need to do is, in my opinion, is to create as many heat sources as possible spread around the space. And so in our kitchen dining room, for example, we put 6 panels across the ceiling. And I put 3 across the living room. And the living room's slightly different because generally speaking, people are sat in one of 3 places. So I was able to put the panels where those people sit. So, for example, if there's just 2 of us and we're sat together on one sofa, we only put that one panel on. We don't need the other 2. If there's a couple with us, we might put their panel on as well. Well, we'll put their panel on as well. We don't want them to be cold. But if there's 6 people in the room, we'll put all 3 on, or 6 or more. So it gives us a bit more flexibility. So by having an array like that, we can zonal the heat, exactly as I said. So you have the choice between heating the whole space or just heating you. And that's massive. We had a situation last winter where I think it was about 5 degrees outside, and we were sat watching television at the end of the day, and we just had one 600-watt panel keeping us beautifully warm. We put on the bedroom one early so that the bedroom would be nice and warm when we got up there. So there was a period when there was 2 600-watt panels on. But for most of the evening, there was one 600-watt panel. And we were perfectly comfortable. Our house used to take 16 kilowatts to heat it. And so we've gone from 16 kilowatts to 600 watts. It's a massive saving. The other thing with infrared is we like it, I think. So it doesn't need so much heat to keep us warm. The manufacturers claim about a third. So my 600 watt panel, for example, if it was a conventional electric heater, would require, 2.4 kilowatts of heat ordinarily. But because it's infrared, it only needs about a third of that. So it's really efficient in energy use. However, the negative is that electricity in this country is really expensive. We're using a third of the amount of energy that we were if we were using oil heating, as we were before. We're in a rural location, oil or gas, so we're using a third of the amount of energy. However, that energy is 4 times more expensive. And so if you shift to far infrared heat and you use it in the same way as you used it with your conventional central heating system, I would say it will cost you more money. However, there's an opportunity to use it far more efficiently, which is what I'm talking about. So if you use a good control system where you can control it so that you've got the right temperature in the right rooms at the right time of day, it will save you quite a lot of money. The warm-up times are shorter. That will save you money. So the system has the potential to save you quite a lot of money. If you use it in exactly the same way as you used your old central heating system, it will cost you more. Okay, so you need to think about this holistically. And the other thing to consider, these aren't terribly expensive systems compared to, say, an air source heat pump or a complete central heating system. It's far cheaper than that. The other thing to consider is putting in cost mitigation measures. So personally, I've got solar panels and batteries. And the batteries are the big one. That's where you save the most money. By buying your electricity off peak, my electricity at the moment is costing me less than 7p a kilowatt hour through the night, which is a quarter of the day rate for that electricity. So that saves us a phenomenal amount. So our heating costs are roughly half what they were before. It's difficult to say exactly. It's always difficult because we had oil. You never know how much you're using. So all I've done is taken how much we've bought over the last 6 years and divided it by 6. That's the best I could do. So so it looks like our costs are roughly half what they were with the oil, but we've had to invest in batteries and solar to get there. The solar really is just a nice to have. I think, as I say, the batteries are doing the real work as far as saving you money is concerned. Obviously the solar's doing some, but the solar doesn't do much work in the winter. You got your heating on in the winter. So it's the batteries that are the big one there. What other interesting observations? Well, one of them is that we have 2 spaces in the house that we haven't heated. And it's the same here in the office. The print room that sits behind me, behind this bookshelf, isn't heated. Our toilet isn't heated here in the office. At home, it's the utility room, the entrance hall, the stairs and the landing. I've got no panels in that area at all. Now, that may seem odd, and it is a bit odd. I didn't deliberately do that. It was just that the entrance hall and the utility room are below our principal bedroom, and we had just decorated it, and we'd furnished it, and we've got a bed that's difficult to move. We've got furniture on it, wardrobes, etc., which are difficult to move. And I would have to take all of that out and the carpets and everything else in order to cable to the panels in the entrance hall and the utility room. And so I didn't. I thought as I said, I did this a little bit piecemeal. So I did room by room and I haven't done those spaces. I'm still trying to work out how to do them. But what's noticeable is we don't get cold in those spaces. This is really weird. So we can walk into the utility room, put a load of washing in the washing machine, polish our shoes, do whatever we do in the utility room. And I've never gone in there and thought, whew, this is cold. Now I used to, with our old central heating system because we never had a radiator in there. We had the boiler in there, which when the house was built, the boiler gave enough heat to keep that room warm. When we changed to a highly efficient boiler, or a much more efficient boiler, it didn't. And so that room was always cold. But now, with the radiant heat, even though it's still not heated, we don't feel cold in there. And like I say, it's the same with the entrance hall, the stairs and the landing. So if we're leaving the ground floor to go to bed, we walk quite a distance through the hall, up the stairs, across the landing to the bedroom. And at no point do you think, whew, this is cold. And that's weird. And it got me thinking, how can that be? How can that ever be? Now I would say a negative, because we haven't heated the entrance hall, when you step in on a cold day and it's cold outside and you're stepping through the door, you don't get that lovely, that's nice and warm. You don't get that until you get to the next space where the heaters are. And then you go, that's nice. But we're not getting that until we get a bit further into the house. So why is it that you cannot heat certain spaces and it's not a problem? I got thinking about this. Now, my belief is that there are fundamental, and it's only my belief, there's no science behind this. I believe there are fundamental differences between infrared heat and our conventional central heating. Infrared heat actually heats us. So in other words, the radiant heat excites our atoms and molecules and makes us feel warm, the same as the sun does when we step outside. So it's warming us. We physically become warmer when we're subjected to infrared heat. The central heating system, our conventional central heating system, cannot warm us, in my opinion. Now that sounds a bit odd, but we operate at a temperature of 37 degrees or thereabouts. Our central heating system warms the air to 20 degrees. So a temperature that's 17 degrees lower than we are. So how can that warm us? So what's it doing? Well, I think it's insulating us. So I think what you're doing with a conventional central heating system is warming the air to a point that reduces our own heat losses to a comfortable level, where we are comfortable. So it's not actually warming us. So if you then move to a room that's unheated, where our own heat losses increase, you feel cold. So on a conventional central heating system, if you've got a room that isn't the same temperature as the one you've just left, it's like on a cold day taking a jumper off and go, whew, that's cold. Because it's not heating you, it's insulating you. That's what I think. Now with a far infrared or an infrared heating solution, you're warmed up so you can walk into an unheated space, and because you are warm, you don't feel cold. And I think that's really interesting. And I may never put any panels in my entrance hall. I may never put them on the landing. I don't think I will. I don't think I'll ever put them on the stairs and landing. I've not yet felt the need, and we've been through a whole winter with this, and I've not felt the need. I'm definitely not going to put them in the print room there, and we've not felt a need for it in the loo in this office. I might do just to improve customers' comfort, but I probably won't. So again, that's quite a big saving. There are spaces that you can look at and say, well, do I really need to heat that? What do I do in a utility room? I don't sit there having a cigarette or a pipe or whatever. I don't hang around enjoying the view out of the window. It's a space of function. You go in there, you do what you need to do in a utility room, and you come out. And if you're warm, you don't need any heat in there. So that's our experiences. So our cost savings, as that's always a big one, are about 50% on the running costs. The other big saving is maintenance. There's almost nothing to go wrong. You've got panels, you've got switches. Now you compare that to a central heating system where you've got a boiler which has got multiple elements in it that can go wrong. You've got a pump or two normally. You've got actuators, normally 2 or 3. You've got the radiators, you've got the radiator valves, you've got the control system, all of those things. You've got multiple single points of failure with a central heating system. In other words, if one thing fails, you've got no heating. If a panel goes down with an infrared system, you've still got all the others, and you just replace that panel. And it's a relatively cost-effective thing. It's not a ridiculous bill of the sort you might get if you get a central heating system failure. You've got no annual maintenance. You've only got a single fuel. So with a central heating system, you've normally got two fuels, gas or oil or solid fuel and electricity. So either of those goes down, you've got no heating. With electricity, you've only got one thing to fail and you've got no heating. But if you've got a battery, as I have, that will function when you've got a power cut. So again, it's a smarter solution, a far smarter solution. We couldn't be happier with it. I never considered the benefits of taking radiators off the wall and putting them on the ceiling. I would have thought it was a ridiculous thing to do. And I know there's been various ceiling level heating systems over the years that have failed, but they weren't using far infrared radiant heat in this manner. We're absolutely delighted with it. And I'm struggling to see a situation where it isn't the best solution. As I said before, we've used air source heat pumps, especially combined with underfloor heating, for, 15, nearly 20 years now. And it was generally our go-to solution. It's not now. I think our go-to solution is infrared panels. I'll be interested in your comments. I'm sure I will provoke a few arguments from this. I'm always happy to argue. Thank you for your time.